Hello everyone. So in this video, I just want to briefly describe how we use this apparatus, which is called a Kennon force platform, to add vectors experimentally. Okay? So first of all, I have one pulley set at 30 degrees, and I have a hanger here with 50 grams on it. And the hanger itself is 50 grams. So this is going to be 100 grams, and it's at 30 degrees. I have another hanger here at 120 degrees, and that is 200 grams. So I have a 50 gram hanger plus an additional 150 gram masses on there. So I have 200 grams total at 120 degrees. So first thing, grams are the units for a mass, right? And we actually want a force. Well, the force is going to be the weight. So we know from, and you guys know this from lecture, we know how to compute the weight, which is the gravitational force, given the mass in kilograms. We simply multiply the mass by 9.8, right, by g. So the weight is going to be mg. So think of it this way. We have a weight pulling down. So it's the weight of that hanger pulling down. I have a tension that's pulling up, so the tension in the string here is pulling up. Now, since this hanger is not accelerating in the y direction, right, it's not moving in the y direction at all, then that tension must equal the weight, right, because the net force would have to be 0. So the tension is essentially has the same magnitude as the weight of the hanger here. The pulley just redirects that force. So you can really think of it as you have a force which is equal to the weight of the hanger, which in this case happens to be 100 grams is 0.1 kilograms times 9.8, so it's 0.98 newtons. So I have a force of 0.98 newtons, and it's pulling at an angle of 30 degrees. Okay? When you read the force platform, by the way, think of it as your typical coordinate system where 0, 0 is off to the right-hand side, right? So this is like my positive x-axis. And then it gives you two scales, but the one you want to use is the counterclockwise, the internal scale, because that goes from 0 to 360, right, counterclockwise. So it's like your typical Cartesian coordinate system where you measure angles from the positive x-axis counterclockwise. Okay, so I have a force of 0.98 newtons pulling out at 30 degrees. I have another force of double that basically, right? So it's 200 grams, so it ends up being around 1.96 newtons, pulling out at 120 degrees. So these are basically vectors, right? They have a magnitude and a direction, magnitude and direction. And I want to add those two vectors, those two force vectors, together experimentally. Now I know my result, right? The sum of those two, so which we also call the resultant vector, is going to be somewhere in between here, right? It'll be somewhere, say, in this direction. Probably a little closer to this one because this one has a larger magnitude, so let's say like that. So the way that we add them is we sort of do it indirectly. I have a third pulley here, and I'm going to vary its direction and the magnitude, how much I put on the hanger, so how many grams I put on the hanger, such that when I pull the pin here, it's not that it stays balanced. It stays right in the center. Okay? So this equilibrant is like balancing out the sum of these two vectors. So what we really want is the resultant. So the question is, how do I find the resultant vector given the equilibrant? Well, it must be the same magnitude, right? Because this equilibrant is balancing out the sum of these two, so it has the same magnitude. So whatever I have in grams here, I can convert to newtons, and that will be my magnitude of the resultant vector. But the direction is exactly opposite, right? Because the resultant will be going this direction. This is exactly balancing it. So how do I find the direction? Well, if it's the opposite direction, I read the direction of the equilibrant, which is 273, and I subtract 180, right? So my resultant would be 93 degrees. Okay, and then of course you can also do this. There's another string and pulley here. We could also add 3 vectors together using the fourth one as our equilibrant. and the resultant will be, again, just in the opposite direction. Same magnitude, but opposite direction to the equilibrium. All right, so that's the general idea of how we add vectors together. And again, I will give you guys the data for the Kennon force platform. Great, thanks.